Assalamu alaikum. I am Tohirjonov Abdulbosit from the Department of World Economy and International Economic Relations. I made a research about the impact of engine displacement on miles per gallon. And I made this research. I collected all data via Stata program, and I have already installed it. And here is how I started my research. First of all, I get a DTA file and do file from my teacher, and here it is. I uploaded my DTA file like this. Open. So here's my DTA file. I already uploaded it. That's why I'm not gonna do it right now. Here it is. Here is two variables: miles per gallon and engine displacement in cubic inch. And second thing is uploading do file. I also have uploaded do file through here. I already uploaded the file. Here mine's. And I also changed all the variables. Here's how I start my research. Keywords: main keyword, descriptive statistics, correlation coefficient, linear regression, and histogram. Here is the two acronyms: MNG, it is miles per gallon, and ENG, engine displacement in cubic inch. In some parts I mentioned MNG or ENG only. And the literature review, how I get the literature review. I get all literature review through the Chrome from the Sign Direct site. I also already registered here, and I searched, for example, main keywords of my research. For example, engine displacement, like this. And I choose three articles through here, and I uploaded to Mendeley desktop platform. And through the platform I checked those articles. I read those articles, and I get main closest ideas is my literature review. And after that, here is the three literature reviews of three different articles. Here's the first one. After putting it to my research, I edit citation to over here like this. I edit citation, and I go to Mendeley site, and after that I will choose one of this, and I just send citation to plugin, and that's all. And after that introduction The higher an engine displacement, the more power it can create, while the lower the displacement, the less fuel it can consume. This is because displacement has a direct impact on how much fuel must be drawn into cylinder to create power and maintain engine operation. And this research project has aimed to try and establish the impact of engine displacement on miles per gallon. And I used quantitative method to get more detailed data. I use Stata 14 software to analyze it quantitative, and I found a correlation between dependent variables such as miles per gallon and engine displacement among 392 observations. And here is the main part of my research results. And we will back to our do file. We would execute our selections to comment menu, and here it is. And then we cannot copy it right now. In order to copy it, we have to add a comment as doc or it's not possible right now because we have to add another comment first. Here it is. Yes, you have to install stock command first. And all good right now. Installation completed, and we can write stock and summarize. And then here it is our table, for example, and I will just copy it, and I can paste it to my research. And after that I have to close this window because it will be difficult for later tables. It will affect for later tables, for future tables I mean. Here I pasted here. And what is this? This is descriptive statistics, the main statistics of the research. This table shows summarized information about the research. The number of observation. Here is the number of observation is 392, and minimum consumption of fuel is 9 miles, and maximum one is 46.6, and average consumption of fuel is 23.446 miles for 1 gallon only. And the size of engine, here it is. The size of engine displacement is between 68 and 455. And second one is a graph. We used a scatter load. To find the relationship between dependent and independent variables. We found that there is a relationship between the miles per gallon and engine displacement in cubic inch. Here is the engine displacement cubic inch and miles per gallons. if the size of engine displacement increase, the miles per gallon will decrease. For example, if it is about 100, it will be 45. If it is 450, it will be 10 or 15, like this. And it is a negative correlation between miles per gallon and engine displacement in cubic inches. And it's easy in data file. Here it is our do file. We will just copy it and we will execute. And here is our graph. And we can easily execute all commands to our research. Move scatter mpg eng left mpg eng, like this. Here's our second graph. The given graph describes the fitted value of variables. We conclude that there is negative relationship between the usage of fuel and the size of engine displacement. And we also tested the Pearson correlation coefficient to find out how much the variables are dependent on each other. And there is a negative relationship between miles and per gallon and engine displacement in cubic inches, which is 80.5%. It is 80.5% negative correlation. And how I get it through do file. Here it is. No, next one. Yes, is our it is our Pearson pairwise correlation test result, and we have to copy it as doc, like and I will open my file .doc. And here we can just copy it through. We can copy it to our research, and we have to close it after that. The fifth one, we analyze the Spearman correlation coefficient to prove the Pearson correlation coefficient. According to this, there is a 85.5% relationship, and the p-value is smaller than, here the p-value is equal to 0. It means smaller than 0.05, and it is statistically significant. In the third graph, we investigate whether the given data is normally distributed or not by using histograms. It is histogram data, and it is normality test. According to this, our results looks like a bell, and data for cells are distributed normally. And according to do file, no, previous one, yes. This is This is our data, and the next one is we'll execute this do file as well. This is next one. For engine displacement is cubic inch for engine displacement in cubic inch, we found that it's not normally distributed because some data are not available here. And we found that 75 first of all we have to open do file again. This is our command grandbox mpg, and here it is. We can copy it, and I already pasted to my research. What does it mean? According to this, 75% of consumption of gallon between 75% of consumption of gallon for mile between 17 miles and 29 miles, and the mean of this in 23 miles. And the next one is graphbox eng. Here it is. 70% of the engine displacement size between 105 and 285 cubic inch. The medium size of the engine displacement is 140 cubic inch. Here is a medium size. We will came back to our do file, swilk mpg. We'll open it. It will be appeared in our statement stata command. Here it is. We also have to copy it from the Word. We will write sdoc command first, and here it is. We'll open my file.doc, and we can easily copy and paste it, and we will close it after that. This is a Shapiro-Wilk test to ensure that data is normally distributed, and if the p-value, here is our p-value, if the p-value is greater than 0.05, it means the data is normally distributed. In a given table, p-value of the variables are lower than 0.05, which means our data is not normally distributed again. And the next one, here it is. I will open it, and I can copy it as well. And this table, here it is. Here it is. This table provided below indicates the most important information about the research. The regression analysis has been used to estimate the consumption of per gallon per mile. The main purpose of its analysis explaining a relationship between dependent and independent variables, and there are 392 observations over here. And our probe F value, here it is probe F. Prop F reveals the imperishability and accuracy of the model, and it should be less than 0.05, and our F model is 0, and it means our model is robust and accurate. And R squared is a percentage of dependent variable variation that the linear model explains. And our model data points are close to the regression line, and independent variable explain almost 65% of the dependent variable. According to the data obtained, the regression model is this formula: miles per gallon equal to it is equal to a constant plus engine displacement inch in cubic inch. This is our variable. And the next one, histogram. The next one is histogram. Here it is histogram. No, this one. Yes, this is our histogram. According to this, we check the normality test for residuals, as the residuals are normally distributed. Because residuals are more than 0.5, that's why it's normally distributed. And here is our skewness kurtosis test for normality. And you can also open it through the Word to copy full table as doc. Here it is. I will open and I can copy it. I will close right now. The next one is we observed linear prediction and its density. The graph below shows here is the graph, picture 8, H8, Y head histogram. The graph below shows that the linear prediction is not normally distributed because we have not enough data for this. Here is our next histogram. Yes, here it is. I copied from this. I copied this histogram and I pasted it to here. The next one is skewness kurtosis test for normality. This is same as our previous histogram. And the next one is here it is. This is our graph. previous one. Is this a correlation between miles per gallon and linear prediction? Correlation between YHAT and EHAT. And I missed one thing above, I think. Yes, here it is. I missed here. I copied from here. I just copied from here and I pasted. This is Bruch-Pagan-Cook-Weisberg test for heteroscedasticity. Variables fitted values of miles per gallon. And our p-value is equal to 0. And the last comment is login. I'll copy it. And I need to execute. And here it is. Yes, here it is our last logit table. There are three types of data here. Number of observation, this is like this, and I can copy it to Word as well as stock. Yes, I copied it from here. And here is a conclusion. According to my research, I found that it has a strong negative relationship between the size of engine displacement and miles per gallon. If the size of engine displacement increases, the miles per gallon will decrease. And here is my references, how I did it. I just wrote references, and for example, let's delete it and insert bibliography, and here it is. Word automatically saved Mendeley desktop history. That's why he just uploaded references by himself. And I can also choose as a style through here, American political science style, for example, Chicago style, IEEE style, and like this. No need for that. And like this. After all of that, I checked all of data if everything right or not through the Grammarly, and here it is. I just open it. I installed Grammarly to computer, and I already checked this research. That's why it's showing only some mistakes. but I didn't change those mistakes because they are in other articles reviews, in other articles datas. That's why I decided not to change those. And that's all I have. Here's my research. I will send via a Telegram group, and thank you. Have a good day.